be looking at something with Delta Math here. This is a lot of vocabulary and introduction to geometry, particularly with pictures and symbols and words, and just trying to make sure we kind of match all those things up. So as we go through these exercises, what I'm mostly aiming to do with you is help make connections between the symbols, the words, and the pictures. Some of these symbols and words and pictures you may have seen already, and some you may have not. This first one, I have a figure here, and it's asking me to choose a symbol and a way to write that symbol that matches this picture with some labels. So first I notice that my symbols are a line with no arrows, a line with arrows in both directions, or a line with a forward arrow, or a line with a backward arrow. I'm going to choose the forward arrow because that's something that we call a ray. It kind of starts at a point and just moves in a direction. This ray here starts at F because that's like the point where there's a single point and the line doesn't continue past it. So it starts at F. Now, I could say it goes and not ends, but it continues through W, and that would work. But if somebody else were to also say, here's a ray that starts at F but goes through B, you would be the same ray. So whether you went through B or through W, that second letter is kind of optional either way. But they start at F, and that's kind of the important piece. So if I were to submit and say, those are the things I think it is, awesome. It does give me the ways to name a ray, so it has an end point. That means like the end of the piece that you're looking at. The second later is any other point that you pass through, so it could be the B or the W. Let's do another one, very similar. That one's a ray, so let's see if we have different examples. Okay, here we have a line. So looking at a line is going to have arrows pointing in both directions, and you just need to pick 2 points, any 2 points on the line. So N and L work, L and N work, RN, NR, LR, RL. Each of those is just a combination of 2 letters because a line goes in both directions. There's not really a stop end to it where it starts and then goes off in that direction. So here was the ray. There's another line. If it just gives you 2 letters, well, it's either PS or SP. It doesn't matter which direction, so both of them are correct. This one's a little bit different here because in this example I see that I have 2 end points where it's not arrows that continue through, but they have stops on each end. But the order, again, doesn't matter. I can say RL or LR. Either way, it's going to work. All right, so that's what we have for our rays, our lines, and our segments, which is the line with no arrows. Now let's look at naming angles. So it's asking me to name this angle, and you might think, oh, that's like angle C. It's up in the C corner. Well, it is kind of in that C corner, but notice that it doesn't cover the whole C corner. It only covers these 2 kind of legs here that go out to A and to B. Well, to cover the leg that goes out to A, so I have A to C and then C to B. I'm like drawing my way around this angle. So to describe that, I have a C in the middle, and then it goes out to the points A and B. But there's not really a order that you have to do that in for the beginning and the end. The C does have to go in the middle, but I could have said B goes first and then A, and I would have still gotten the same thing. There are occasionally other ways that a diagram might be labeled. So let's see some of those examples here. So this one has the 3-letter format for the way a diagram might be labeled. Similarly, this one, I don't see any number angles. So that must be it. Yeah, we're focusing on the 3-letter method for naming angles. Oh, so this one has 3 different versions. Here's one kind of possibility to expand it. You could have the VTU where the T is in the middle, but it goes to V and to U. Or you could have UTV where T is in the middle, but it goes out to U and V. Or because this is in a corner of like a triangle or some sort of shape where that corner just as easily identifies the exact angle that I want, I could simply call it angle T. But that's only if it can't be confused with anything else. So for example, in this previous one, if I said angle S, well, do I mean this piece here that they have shaded? Do I mean the other space that's not shaded? Or do I mean the corner that goes both spaces combined together? So if it's ambiguous or it could be more than one option, that's where you have to use your 3 letters to define it. Now we have some markings on a diagram. There are such things as parallel. There are also congruent, and there's right angle corners. You've probably seen right angle corners with like a square in the corner of an angle. Congruent is either marked by these hash lines, where it's like 2 lines are marked or 1 line is marked, but those 2 lines being marked in the same way is saying that X, Y, and WY, that those segments are in fact equal to each other or congruent to each other. These arrows mean that the lines UV and WX are parallel. And parallel is just saying they kind of point in the same direction. Not kind of, they do point in the same direction. And they will never, they'll run alongside each other with never crossing over. So let's look at some of these examples. Here's an example of parallel. The red and the green are highlighted as parallel markings. Perpendicular is a really long word that just means 2 lines that intersect with a right angle. So because the blue line and green line intersect with a right angle, that means that they are perpendicular. Congruent is when a pair of things have the same markings. So this says 2 segments that are congruent. Well, DE is a segment, and it's congruent to BE, which is also a segment. And here we have 2 segments that are marked parallel. We've seen that one before. Let's see, 2 angles that are congruent. So these happen to have a marking. We sometimes call this like an arc, that rotation measure of how far it rotates in that corner. And the angle S, the rotation mark, and the angle R, I shouldn't say S, PST and SRT both have the same marking in the angle. So that makes them congruent. So let's try to answer this one. We have UV and XW. So UV and XW are both parallel because they have those arrow markings. I'll continue on, see if I get a different one. Now it's saying which markings are congruent, and it wants segments. So I need to find 2 segments. So I notice that PN has some markings and PM has some markings. So I'll say PN, let's make that capital. PN, capital PM. Those have pairs of markings that go together. And it says correct. I could have marked NP or MP. I could have marked it in other ways as well. Let's see if this last one says 2 things that are, we already did segments that are congruent, so we'll leave that alone. Bisectors. Ooh, okay, what's bisect? What's midpoint? What's vertex? So a vertex is when you have things that meet at a corner of any kind. So each of these points happens to be a vertex because it has more than one kind of line colliding into that corner. But this is asking which statement is true. For something to be a bisector, that means that it splits something else into two equal halves. So KL does in fact split this side into two equal halves, so that's true. Is KL perpendicular? No, I'm not going to say so, because perpendicular means I needed a 90-degree angle, and that's not happening here. Does KL bisect an angle? Does it cut in the middle of an angle that was rotating? It's not doing any cuts on the angles. Is it a vertex of one of a pair of congruent angles in the diagram? So is it a vertex of one pair of congruent angles? Well, it might be, but it's not marked, so we don't necessarily know. And I would argue that it is, but it's hard to tell that this angle has a marking for, it doesn't show any congruent marking. K is the vertex of a right angle. Nope, it's not the corner of a right angle. I don't see any right angle markings there. L is the vertex of a right angle. It looks like a right angle, but it's not marked. So many of these are possible, but it's not necessarily true if it's not marked. We're looking at what's marked, not what it looks like, but if it's actually marked. Let's see if we can see some different examples of what's going on. I notice here that I have these two markings that split that into two equal halves. So V we would call the midpoint. You could also say that this segment VW is a bisector, or it's cutting in half the other segment SR into two pieces, SV and VR. So what would have been true in this case? VW is a segment bisector because it's slicing in half a longer segment. And V is the midpoint of that longer segment. Here, I don't have necessarily anything marked, but I could say that this angle here is congruent to this angle here because of these twin markings. Those twin markings say that those would have been congruent angles to each other. So if they asked us, is N the vertex of congruent angles? Yes, it is. Or if R is the vertex of congruent angles. Here we go. Now we have two angles that are not only marked as kind of twins where they're equal to each other, but they're also kind of butted up against each other. So they are split as one larger piece into two smaller equal pieces. That means that the angle was bisected, or the angle was cut in half. So this line HI is cutting the total angle into two equal halves. So again, we have some markings for midpoint because two sides are equal on either side of it. This one, we don't have any midpoint stuff. We do have a right angle, so you could say FH and GF are perpendicular to each other. There's a few other ways you could say it, but essentially, if you saw perpendicular about those two segments, that could be true. We saw one that looks like this. Here is one that's kind of like, it's got a lot of stuff going on. We have NO cutting in half LM, and it goes all the way down here. And that means NO is a bisector, so it cuts that in half, but it's also perpendicular. And when you're both, it gets the name perpendicular bisector. So it's a segment bisector, it's a perpendicular bisector, N is the vertex of a right angle, and N is the midpoint. It's the middle point between L and M. Because if each of these sides was like 3 on one side and 3 on another, N would definitely be in the middle. Okay. Identifying angles from 3 points. What this is asking us to do is kind of carefully use our mouse or finger on a screen to draw an angle in a corner. They're looking for angle DIA. That means I is in the middle, so I'm looking around for where is I. Here it is. Now I need to find the legs D and A, and that's these ones. So I'm going to use these 2 dots that are on the D and A segments to draw. I'll click and drag to like pull this angle as a rotation. And that's it. I just have to kind of drag or open that angle in the correct corner. And I'll click on it. And it says, yes, that's correct. Let's try another one. BCD. Well, C is in the middle. So I'm looking for point C. Here it is. And I'm looking to go out in the directions of B and D. So C is in the middle. Here's my B, and here's my D. So this one's kind of interesting because I'll start dragging maybe from B, but I'm going to go all the way around until I hit the D line. And now that full angle there, it looks like it's 2 angles put together, but that full angle is the one that we were trying to get to. Let's try one more. AHD. Well, H is going to be in the middle. I need to go out to segments A and D. Well, here's my A, here's my D. So this is another larger angle that goes across 2 points. Or 2 angles that make up that larger angle. Okay, now we're just going to try and guess like the size of angles. We know that a quarter turn would be 90, a half turn would be 180. This picture does not, or this tool does not go all the way around in a 360. It's only going up to a half. And it's asking us to approximate 98. Well, that should be just a little bit above 90. Let's try that. This is to help us visually start to identify how big an angle would be. And similarly, if I'm going to draw 150, well, here's 135, here's 180. 150 feels about in the middle between those. It might be a little closer to 135, but let's see what we have. Let's try this. So it was a little bit closer to 135, which was true, but I was pretty close. Okay, now drawing angles level 2 is, oh my gosh, I don't have my markings, so I have to think about where was 10 degrees. Okay, well, a quarter circle is 90. So halfway to a quarter circle would be 45. So then I got to drop even more to get down to 10. It might be here, might be like halfway. Let's try this one. So I needed to get to 15 degrees. I misread that. But they give me as much as 10 higher or 10 lower. I was hitting at about 23, but that was close enough to 15. This next one wants me to hit 70 degrees. Well, again, I know 90 degrees is straight up, so I could go straight up and then come back a little. Let's see if this is close enough. Ooh, we are just close enough. Now let's see if we can not draw them, but estimate them. So this is saying, how big is this angle? Well, straight up would have been 90. A quarter would have been 45, half of that. So I'm going to say it's a little bit above 45, maybe it's 50. And I was still off, but I was close enough. This is, again, trying to get you to estimate approximately how big an angle is, knowing where 90 is straight up or 180 is all the way in the other direction. This one's a little bit harder because your bottom line might not be flat, but it looks like not too big. It's not a full quarter turn, and it could be maybe even half of a quarter or half of 45. So half, we got 90 degrees would be perpendicular. Halfway to 90 degrees would be 45. This looks like maybe 30. Let's try 30. It's a little bit less than 45. And it was. 45 was about there, halfway to perpendicular, and it was a little bit less than that. Now these next ones I may or may not include how to like estimate an angle bisector, but what we're trying to do here is find a line that's in the middle. So I want to draw a line that splits those two halves into two equal pieces. So I'm going to go about there. That looks good enough. And I was close enough. It even gave me the same angle for each one, 23 and 23. So, I drew one that was at 21, which was off by a couple of degrees. But I'm just trying to split this angle. Let's try that again. So this one's a little bit wider. Like this is lots of purple, not very much green. Lots of green, not very much purple. I'm trying to split them in half so I can eyeball or guess or estimate where that halfway bisector would be. Click submit. There we go. Now this last one is going to ask us to do that same thing but with more precision. So it's going to show me some numbers. Do you notice how it has these numbers up here, a 13, or now it's a 91? But I want to split those angles until those numbers are equal. Okay, I got a 47 and a 47. Then it's going to ask me a question. And it's asking, if I look at these angles as like the purple, the green, and then the total, how could I describe them as a formula? So we have here GHJ, that's just the green. And then I have IHJ, that's the purple. Is 2 times the purple equal to the green? That's not true. They should be equal to each other. So that one can't be true. Let's look at the next one. GHJ, that's the green. IHJ, that's the purple. They should be equal to each other, not half of the other. Well, let's keep trying. Now I have GHJ, again, that's the green. IHJ, that's the purple. Still not quite there. It must be this last one, but let's see why. IHJ is the purple piece. GHI means I have a middle of I, and I'm going all the way from G to I. So that's the total angle, both pieces put together. What this is saying is if you took both pieces put together, GHI, and took half of it, just one side or one rotation, that would give you the other piece here, the IHJ, is half of the total rotation. That one's quite a bit harder, and I think for now, I'm going to actually take that one off. We'll keep it just to the drawing and the naming of things. But use this to kind of help work your way through the material. You might be able to work through faster than my own demonstration, and that's totally fine. A lot of this is from previous things you've learned in other courses, but it has been a while since you've seen it. Thank you, and have a good day.